way. The first presentation is coming from my colleague Gerardo Viviers about the routing security, and he will give us some insights about the regional statistics as well. Yeah.
Thank you. So, in about 30 minutes, your digestion is going to start kicking in, and so you won't be paying any more attention. I'll have to be quick so that I can get my message across. We're going to be talking about routing security, but focusing mostly on RPKI, because all the other techniques that you might be using are already known and familiar. So I want to talk about something, the new kid on the block. Basically, we have routing, which is done by BGP. But BGP is naive. If you have two BGP peers and they exchange routes with each other, they will just accept them with no questions asked. So BGP has no mechanism. When the peer connects and says, hey, you, hey, what's up? Well, I have the network, why? What do you think BGP will do? It'll just accept it. Okay, I'll add it to my routes. And goes happily on, and everything goes on. What happens is, because BGP is so naive and allows all the routes to enter, is that you get all kinds of routing incidents, like the famous typing errors, which we like to call fat fingers. And it's not because people have fat fingers, but it looks like they have really fat fingers. And when they're typing in an address or a prefix, they type in the wrong number. You know that the 2 and the 3 are very close together, and it's not the same to announce a /22 than it is to announce a /23. Other incidents that happen is you have routing policy violations, like, for example, leaks, filtering misconfigurations, all these kinds of wrong information. And because BGP is just, open to anything, it passes it on without doing anything about it. There's nothing built into the protocol itself. And then lastly, you will have, of course, the malicious attacks, which you probably have seen happening more frequently because something happened in the internet world that is making some actors out there do bad things. Can you imagine what it was? No? Starts with IP and ends with V4? Runouts? Because there's not really much IPv4 out there anymore, lots of operators who need the address will just try and go and use it, especially the malicious attackers or players. Thing is, you can do route manipulations, BGP hijacks, BGP DDoS. There's all kinds of situations that happen because of these malicious actors. And then the question that arises is there anything we can do about this? If only we could try to fix this problem. And of course, you'll all say, duh, we already know what to do. All we have to do is filter, right? So you set up your BGP filters. You can do it based on best practices. For example, filtering out bogon prefixes, prefixes that shouldn't be seen on the internet because they haven't been assigned or allocated. You can also filter out prefixes which are well known, which you should not be using. For example, documentation prefixes or benchmarking prefixes, stuff like that. Then you have, of course, all the private address space. Don't forget that. Then you have the information that's inside the Internet Routing Registry, root and root 6 objects, which you should all be creating. And of course, all network operators should be creating. There's lots of transit providers, internet exchange points, which will not accept a route if it's not registered in the Internet Routing Registry. And last, you can also filter routes based on RPKI, which is the newest thing that the internet community has developed. All of these filtering options are part of something called manners. Have you heard about manners? Good manners? Yeah. The mutually agreed norms for routing security promoted by the ISOC, which we had a great presentation in the morning. And what they say is, in order to keep a stable and operating internet, we need to filter out these routes which should not be there. And what I'm going to be focusing on is filtering based on RPKI. Now, the RPKI system has been adopted by all 5 RIRs across the world, so they're all in it. It's not incomplete. All these RIRs, they know to whom they are issuing address space, to whom they are giving an allocation or an assignment. And that's why they are called the trust anchors, because we have done our due diligence, we have checked that the organization or the person exists and where they are and who they are and how to contact them. So every time that we issue address space, we create also a certificate for the holder of the address space. And the holder of the address space can then create what is called a ROA. That's a root origin attestation certificate. And it says what you see in BGP should match what's inside this certificate. So when you are setting up your filters, if you are using the ROAs, they will be downloaded to a validator, which is simply a piece of software that checks if the ROA is the certificate hasn't been tampered with. And then that validated certificate is going to be passed on to the router, which then can take routing decisions that you have decided based on the information in the ROAs, right? So it's a certificate system where it's much more difficult to falsify information than it is with the routing registry. And I'll explain about that in a couple of slides. So the validator creates a valid cache with the ROAs, and that is passed to the router, which will then make the routing decisions based on what your routing policies are. Basically, to do routing security with RPKI, it's very simple in a nutshell. The RIRs are the trust anchors. They send the certificates to the RPKI repositories. The routers will then, through the validators, download the different certificates like this one. ASNK is authorized to announce prefix Y. Now, ASNK is on the internet and starts announcing the network Y. Hello, I have network Y. The router, based on the filtering rules that have been set up by the network operator, what do you think we will do with this announcement? Accept it, right? I hear somebody, accept it. Yeah, they will accept it. Perfect. So that route is legitimate because the document here says ASNK is authorized to announce prefix Y. Now along comes ASNX. And ASNX thinks, hey, I'm going to announce prefix Y as well because I don't have IPv4 and I need to do a spam run. Or I don't have money to buy IPv4, so I'm going to use it anyways. Whatever the reason, ASNX announces also network Y. And based on this document, then, the router should then do what? Not accept it. Yes, not accept it. It should drop the announcement because the document, the ROA, it's a certificate, says only ASNK should announce prefix Y. And this way, only that ASN will be accepted in the routing table. This will avoid the incidents that we saw at the beginning, or at least try to avoid. The benefits that RPKI offers you are multiple, but I'm going to focus on 3. First of all, it gives you proof of origin. So when you start announcing your prefix on your router, there's nothing on any device that would stop somebody else from announcing your prefix as well. Even though the RIPE NCC says you have gotten the prefix Y. But me, I'm a bad person. So I go to my router and I configure prefix Y. And there's nobody that can stop me because it's just a number. There's nothing material. There's nothing, that can stop me from typing these numbers in my router. So RPKI offers you a proof of origin. It says when you start announcing your prefix, when people are checking the RPKI repository, they will know that you are the legitimate person or organization that is announcing and using this address space. Another benefit that RPKI gives you is cryptographic identity verification. On the internet, we're all dogs, right? That's what they say. We can all be cats, we can all be dogs. Nobody knows. No, that was it. On the internet, nobody knows that you're a dog. You could be sitting behind the console and nobody knows who you are. But our PKI allows people to verify that you are an existing organization and that you're not a dog, that you're actually a company that is registered in the registry and that is a legitimate holder of address space or of resources. So our PKI allows you to verify that. And the third, and actually most important, is that our PKI allows you to prevent route hijacking by checking the routes that are arriving against the ROAS to see if the announcement is actually a legitimate announcement. You can avoid that your routes are being hijacked by creating the ROAS, but also by checking the ROAS and doing routing origin validation. So checking that what's in VGP is what's in the ROA and dropping invalid announcements. You are also contributing to stopping route hijacking, which is very important nowadays on the internet if we want to keep it stable. So 3 benefits. Now, we talked about using the internet routing registry. The routing registry is good, but it has some downsides compared to our PKI. If we compare the amount of ROAS that are out there covering address space and the amount of root and root 6 objects, what we would have to ask ourselves is what percentage of these prefixes is in the IRR and what percentage, how many of this is covered by ROAS? And I've seen a study on this, and apparently there is more covered by ROAS than there is by the IRR. And that's because the IRR is not maintained very well. If you remember, the Internet Routing Registry is a set of multiple databases, routing databases around the world, but they don't mirror each other. So the information that is in one database, for example, the REDB, might not coincide with what's in the RIPE database or in the APNIC database or in the the Japanese IRR or, any of the other 30 databases around there. So the thing about our PKI is that it has an advantage, is that all 5 RIRs are standing behind it. So we can confirm that the information in our PKI data system is correct. It's not incomplete. And it's always voluntary. If an operator doesn't want to certify their resources, that's fine. It's their option. But we can always verify who is the legitimate holder simply because the RIR is behind it. Now, in order to understand how our PKI is doing in Bulgaria, much better, we're going to use some statistics. And you've probably heard some of this already in the morning session. First, let's look at the routing statistics. Now, I took this about a week and a half ago or 2 weeks ago, so it's a little bit outdated, the information. I know that there is much more IPv6 being announced now than there was 2 weeks ago. So this number should be higher, like around 555. We see in Bulgaria 631 ASNs, which are announcing 7,765 IPv4 prefixes. That's a lot of IPv4 address. And then we have 437 IPv6 prefixes. From all this address space in announcements, there is around 83% of the IPv4 address space that is covered by ROAS. And we saw already that the organizations that are doing this mostly are not exactly Bulgarian, but we do have a couple of other Bulgarian LARs that have participated and collaborated and allowed to reach this 83%. Now, this is good. This means that in Bulgaria, the network operators are worried and are concerned and are conscious that they have to certify their address space in order for it not to be hijacked or taken or used by other organizations. But that only happens if you do root origin validation. It's the only purpose of creating ROAS is so that you can do root origin validation, checking against BGP. If we check the other countries in the neighborhood, we see that Bulgaria is quite fine at 83% of all the address space. Only Croatia and Macedonia are lagging behind and covering their address space with ROAS. But about root origin validation, that's only the other half of RPKI. Certifying your address space is one thing. Verifying against BGP is the next thing. And actually, this is where the power of RPKI is seen. This is where the potential for routing security comes on top. If we check the world stats on who is doing root origin validation, we can see that not everywhere it's happening. We have a couple of countries who are quite green, like Greenland. Well, there's probably one network there. Somewhere in Africa, we have Scandinavia, of course. They're always progressive-minded, so they like to do things ahead of. We can see that in Europe, half of it is doing it, half of it is not. Also in Asia. So it's slowly picking up as the network operators realize that they've only done half the job, creating the ROAS, but not doing the validation. Now let's zoom in into the area, into the region, and check on the regional stats. We can see here that Greece and Romania, they're doing almost half of the networks doing root origin validation. Then Montenegro is halfway there, and then we drop all the way to the 11-10%, Croatia, Bosnia, Albania, and then Bulgaria. Doing 6.2% of the networks are doing root origin validation. And now this is something that's interesting because you have a lot of the address space covered by ROAS, but you're not actually using that information, that data. And what we wanted to know is why? Many ROAS, very few ROVs. What are the obstacles? Is it lack of information? Is it lack of training? Is it maybe not knowing exactly what the ROV part of RPKI means? As one of the trust anchors, we really would like to know how we can assist you to take that next step and do the root origin validation, to actually put RPKI into use. And for that, I'm not going to take the time now because I just came to talk about these issues. I would like to invite you to participate tomorrow in the ROAS signing party, where we will help all the operators who haven't signed ROAS to create them. But we will also talk about ROV and why it's not happening, because that is for us important to know. Also, I guess for you guys, because that's part of taking the step towards routing security. That's my presentation. Does anybody have any questions? See, I told you digestion will start kicking in and we're all going to be sleeping in about 10 minutes. So I'll try to hurry up. If there's no more questions, then thank you for listening. And I hope to see you tomorrow at the ROAS signing party.
Thank you very much, Gerardo. And the next presentation is coming again from my colleague Bart Becker about the routing security. Yeah.